In this video, we're going to look at these examples on page 8 of the 7.3 slides. Our first question involves two mutually exclusive events, E and F, with the probability of E being 1/10 and the probability of F being 6/10. We're asked to compute the probability of the intersection of E and F, that is the probability of E and F, the probability of E or F, the complement, or not the complement, but the word I am looking for, sorry, I always forget these words when I'm not teaching that specific thing. Anyway, this is E or F, the probability of the complement of E or not E, the probability of the intersection of not E and not F, and the probability of not E or not F. So, first things first. We've got our probabilities here. Probability of E is 0.1, and the probability of F is 0.6. So the probability of the intersection, the probability of E and F, is 0. They're mutually exclusive, so they have no intersection. Therefore, the probability here is 0. Now, for B, we're asked the probability of E and F. And this probability is just going to be the sum of these two probabilities because they are mutually exclusive. So that's 0.1 plus 0.6 is 0.7. C, we're given the probability of the complement of E. Well, that is the same as the probability of not E, which is going to be 1 minus the probability of E. So that's 1 minus 0.1, which is 0.9 or 9/10. Next, we're asked for the probability of the complement of E and the intersected with the complement of F. Well, this is basically saying we're looking for something that is not in E or in F, which is the same as saying it's not in E and F. So that's going to be 1 minus the probability of E and F. So that's 1 minus 0.7, which is 0.3. Finally, we're asked for the probability of the complement of E and the complement of F. But that's just the probability of the complement of E. Sorry, this should be complement of E or the complement of F. But that's the same as saying the probability of the complement of E and F, which is 1 minus the probability of the complement of E, probability of E and F. So that's 1 minus 0, which is 1. Everything is either in the complement of E or in the complement of F because they are mutually exclusive. Moving on. In this second example, we're told to let E and F be two events of an experiment with sample space S. We want to know if P of E, the probability of E is 0.2, 2/10. The probability of F is 1/10, and the probability of their intersection is 5/100. And we want to compute these three values: the probability of E or F, the probability of the complements of E and F, and the probability of the complement of E intersected with F. Okay, so to find the probability of E and F, we'll use our addition rule, which is the probability of E plus the probability of F, this is part A, minus the probability of E and F, which gives us 0.2 plus 0.1 minus 0.05, which is 0.25. Next, so 25/100 there, we're given the probability of the complement of E and the intersected with the complement of F. Okay, well, that's just going to be 1 minus the probability of E or F. So that's 1 minus 0.25 or 0.75, 75/100. Finally, for C, we're looking at the probability of the complement of E intersected with F. Well, that's just F, the probability of F, minus the probability of their intersection. So that's 0.1 minus 0.05 is 0.05. That's it for this video. If you have any questions, please get in touch.